Hey friends, it is .NET Conf. We're here on day 2. I want to remind you that it is a 2-track .NET Conf. We've got Room A and Room B, Channel 1 and Channel 2. This channel is going to have Don Schenk. He's a Director of Developer Experience at Red Hat. And he's going to talk about some deployment techniques, Linux containers, and .NET Core 2.0. We're thrilled to have Don here today. Make sure that you queue those questions up. If you're watching on Channel 9, of course, the questions are right there at the bottom. And at the end, we will have a more interactive chat with Don and ask him those questions. But for now, I will turn it over to him. Thank you, sir.
All right. Thanks, Scott. So I'm calling live from York, Pennsylvania, and you all know York peppermint patties, so that gives you an idea of our only claim to fame. So let's talk about some deployment techniques and Red Hat Linux and Linux containers and .NET Core 2.0 and where we are now, where we're headed, and what you can do with this. It's pretty cool stuff. As you know, Microsoft loves Linux. That's a big deal, something we're real happy with. And the love is reciprocated. So that's just we're all in love here. That is actually our vanity URL also. If you go to redhatloves.net in your browser, it'll redirect you to the .NET side of the Red Hat developer program. So let's talk about why we are where we are. In other words, today here in this session. And we're here today because of where we are in IT, and that's the bottom, going across the bottom of this slide. You see DevOps and microservices and containers and cloud, right? Everything is maturing or evolving. I still remember taking, not a DVD, a CD and dropping it into the CD drive of a server to install, framework, .NET Framework 2.0 or 1.1, whatever it was, and go in on a weekend and update 3 servers, and then cross your fingers that hope everything installed correctly and works after you did the update. And yeah, now we're down to containers where it's just like, oh, it works. Just throw it in the container and it works. We're good. Theoretically, microservices. That's something I'm going to talk about today and try to dissuade you from them, not persuade you, dissuade you, because like anything, you shouldn't do it unless you have to. And then if you have to, you want to do it well. But don't jump into microservices just because it's cool. Because people did that with case tools back in the early 80s, and they're sorry. DevOps, that's a whole mess right now in terms of different people have different definitions and different ways of doing it. Let's just agree that we're all evolving and moving toward an atmosphere where developers and operations actually get along and do stuff together, and putting more and more things into code that they can test and make it repeatable. That's good. And then the cloud, which is someone else's computer. That's what that makes it easy to tell my family members that. So here are the obligatory buzzwords. You can't have a talk without buzzwords. So Linux containers, I'm just, here they are. Look at them. Kubernetes is really the star today. And the way I'm going to use and show off Kubernetes is our product, the third one down there, OpenShift. Sorry about that background noise. Yes, I am the last person in the world who will give up their Windows phone, and that's what that was. And for those of you playing the .NET Conf bingo, I just gave you 10 points. So OpenShift is our product. It's a wrapper around Kubernetes. So I'm going to use it. One, I'm familiar with it too. It's our product, so why not? But it just makes it easier for me, and it has some shiny pieces that look nice, so that's always good. But Kubernetes is a star. When we're done today, I don't want you walking out thinking, oh, and OpenShift's awesome. Although that would be great if you did. But what I want you at the end of this is to go, man, with containers and Kubernetes, you can do some really cool stuff. And I shouldn't say cool because, street rods are cool. But I mean, things you can use. Zero downtime deployment. There's 2 of them I'll show you: the blue, green, and the canary. Just what they are and how that works. And there's zero downtime, which is pretty slick. And then the circuit breaker pattern. That's what I call where we put our toe in the water and try to scare you out of doing microservices. And it's just one part of microservices, one tiny part. hopefully, again, to dissuade you unless you absolutely have to. But circuit breaker pattern also, if you're a web developer, and most of you probably are, it's something you can use today. And if you're a back-end developer, this is something you can walk away with today and go, wow, I can use that. That's awesome. And it really is cool. Sorry, I don't have a cough button, and it is hay fever season, so bear with me. Some of the issues, deploying software just takes too long. Come on, it does. It just takes forever. Software is way too complex, and we're not going to solve that. No one is, until we have, English language, Star Trek computer do this. Because even in microservices, here's what you're doing. You're taking the complexity out of the code and putting it into the architecture. And let me give you an example. You get a new job, you sit down, you open Visual Studio, and you have a solution with 42 projects. And it's like, oh my gosh, look at this. So someone takes you to a whiteboard and draws, circles and arrows and squares and explains some of the stuff. And you're like, that's a start. And so you have this monster, the majestic monolith. Well, microservices, you don't have that. You open up and you just have this little piece of code, and it's real simple to understand. And it's like, oh, wow. So it's not complex. Yeah, but you have so many microservices, and the way they interact with each other, that's where the complexity comes back in. So you're not really getting away from it, from your system, but you are going to benefit from it as a developer in terms of what you have in front of you at that moment. My favorite microservice story, I'll just jump into that right now. There's a tool called Wunderlist. That's a to-do list. It's a great little to-do list. And Microsoft bought them. And Wunderlist uses microservices. And you might think that's kind of goofy or overkill, but not necessarily. But the cool thing was I saw a video with the owner, the founder, and he said one night one of their services went down. And so someone opened up and looked at it, and it was written in Haskell. And the person who looked at it isn't a Haskell developer. So in 15 minutes, they rewrote the microservice in C#. They just, I'll just rewrite it. That's what microservices bring in terms of away from complexity towards simplicity. It's like, I can look at this code. I don't write Haskell. I don't know Haskell. I can figure out what it's doing. I know how to do it in C#. I'll just rewrite it. And it's small and fast, and that's where we get away from the complexity. And it takes forever to scale up or down. It used to be you get faster hard drive or more memory, and then you got the VMs, and we thought they were fast, and it just takes forever. Now with containers, it takes almost no time. So here's the evolution today. The first step, by the way, I hope you like this slide. This is called Don gets a Microsoft Surface Pro and a pen and decides to do his own slides. Obviously, I have to go back to art school. It runs on my PC, which is for most of us, that's where we just, okay, it works. we can go home. But that's not really what we want. So then we're going to run it in a Linux container and talk about some of those benefits. And then the third one, OpenShift, is our platform as a service. That's where Kubernetes enters the picture, and that's where the magic starts to happen, which includes the zero downtime deployments and the circuit breaker pattern. I'm going to be using, for this, our Red Hat Development Suite. It just has all this goodness, and it's free for you. So that's nice. You get Docker, Kubernetes, OpenShift, all this good stuff. My environment, by the way, is a Mac, and I'm running Parallels that has Windows, and then I have a RHEL VM. So I have 3 operating systems. I'm doing everything I can to break everything. So the first thing we're going to do is go over to the command line and run this application. What's this application do? It's just a very simple, it returns the name of the host. So if you had a microservice that returned one thing, this is what you would think. So it returns the name of the host running the app, because for this demo that works out really well. So if I go here and run this at .NET run, it's going to sit there and monitor port 5000. And now I just go over to a browser and go to that port, and I should see the name of the system. I should see. And here's another thing I have. I have a script that runs in PowerShell. And what the PowerShell script does, it does a curl every second against the port 5000 on that VM. So there it is running, and you can see each request. So the name of the host is rel cdk. That's what you get. If you see here, rel cdk, that's the name of the machine. So we know it's working. I'll be doggone if I know why it's not working here, but 10.1.2.25000. So there it is working. It works at the command line. Okay, we're done. We can go home, and but that's not really, we can't just do that. I just had a great success. I was able to restart my PowerPoint where I left off. To me, that's a good day. So let's talk about containers and what they are. On the left, you have the VM that everyone's familiar with, right? The host operating system. Then you have the hypervisor, like Hyper-V, for example, and then you have the guest operating systems, and then the applications. And in that model, when you want to run an application, you have to install the guest operating system, and then you have to install your dependencies. Maybe I have to install NPM and Rails and Ruby and who knows what else to get a Ruby on Rails application running. I have to install .NET Framework or what have you, and then you have a VM. Versus containers, the host operating system, Linux, it doesn't matter which version of Linux you use, whether it's RHEL, Red Hat Enterprise Linux, or Debian or Ubuntu. It doesn't matter, because containers use the Linux kernel, and inside what runs in a container is known as an image. Just like VM, you can save the image, but think of a containers as real small images, real small VMs, kind of, in the sense that you get all the supporting files, the dependencies, and the application or applications, all bundled into one. What that means is you can take an image, which is where the dotted line is. That would be an image. So here's some terminology. You have an image that you build, and then when you run it in a container. So it's kind of accepted when you're talking about an image. It's not running in a container. It is running. So if you hear, that's a container, an image, there might be some, they might use the same term interchangeably. But in a container or an image, you have everything ready to go. So an image is sitting there. It's just bits. And then when you start it, and it starts very rapidly, it runs in a container. And then the cool thing is, you can take that image and you can ship it around. You can save it, restore it. You can upload it to the web, to like a repo, like a hub. You can have a corporate hub. I mean, you can do whatever you want with that image. And I can take it, and if my host operating system is Ubuntu and I have Docker installed, I can run it there. And then if I have a RHEL system with Docker installed, I can run it there. So that you've taken a lot of the requirements away that you had in a VM, the hypervisor and all the dependencies, and you just made it a lot easier. So that's the joy of containers. That's one of the things it gives you. The other thing it gives you is they start pretty quickly. So now, before I build it, I'm going to compile my code, and I have this publish command. I apologize. I don't know why it does this. It doesn't. That's the command line, but here's the actual command. And I'm publishing the command. I'm publishing the software. It's a release, and I'm targeting the runtime of RHEL 7 64-bit, so it'll run on a RHEL system. This is not a self-contained build. If you're not familiar with .NET Core, real quickly, you can either have a build can either be self-contained or it can be portable. Self-contained doesn't need .NET installed to run. This is not self-contained, and I'll show you why that is. When you do a Docker build, when you build an image with Docker build, you use what's called a Docker file. And the first thing you do is you specify your starting point. So in my case, I'm saying use .NET. I'm using RHEL 7 that has the .NET 2.0 runtime already installed on it. which is kind of convenient. I mean, you don't have to install, .NET. You don't have to run through all that. You just say, well, give me that. Red Hat gives us that, so I'll use it. The way you get to this, by the way, if you're not a Red Hat customer, not familiar with our model, is the way Red Hat works is you get a subscription with us, and you pay for it and you get support. Except for developers, you can get a free one. And when that gives you access to our registry, so then you can get the .NET stuff. If you just went out and ran this now, it wouldn't work unless you have a subscription. So then I take the code that I built from the published earlier, and I copy it from my system into the image in a folder called app, a directory called app. And I set the working directory. That's kind of self-explanatory. And then expose 5000 just says, this runs on port 5000, so make sure it's available to the world. And then this command is, when you say, so those first 4 lines will build the image. When you run Docker run, it looks for this command and says, okay, this is what I'm going to run. And typically this would just be .NET run. But because of some funky, just the way Red Hat does stuff, this is what you need. It's not a big deal though, because as you're a developer, you're just going to take this and copy and just change this line to your program name. So that's the name of my program, .NET MSA's microservices architecture. So if I publish this, which is going to compile it, it's going to create a DLL, and then when I do the Docker build, it will take that DLL, and as you saw in the Docker file, Docker build. Now here's something really cool. You have to tag it, right? Give it a name. I'm going to do a really bad example here and name it something other than my program name, which there might be times you do that, but typically you don't want to. So maybe this isn't the best practice, but it stresses to you that your program name does not have to match the name of your image. So it's going to pull everything down off the interwebs. It's pretty fast because I may have it cached. So I've done this before. And when it builds an image, it does it in layers, which is really cool. And each layer has its own SHA. So it pulls down, right, Red Hat, Linux. That's step 1. Step 2. So if it broke in step 3 of your build, and some of these Docker files can get pretty complicated, when you rerun it, it'll skip the successful steps, which is nice because if you have a monster Docker file and it does a lot of things and you have to rebuild it, and especially if you're pulling, like you wouldn't want to pull this. I mean, it's cached, but you wouldn't want to pull that every time. So now I should have a Docker image. So let's see what we have here. Yeah, it's there, right there. I called it .NET Hello. It's 33 minutes old because before I came on, I built it. And that's another thing. If it's built, remember I said it does it in layers, and it skips the ones that are already done. Well, in my case, it had already done all 6 layers, so there's really nothing to build. So when I ran Docker build for you live, it was just going through the motions. It had already been built, just to save time. So now I have a Docker image. I should be able to run this and see it. So here in the background, this app is cranking along, or should be, and it's watching port 5000. Now, when I restart this, it runs on port 5000, but in a Docker container. Docker run. D is start this and come back to the command line, kind of like a fire and forget. It just, runs it in the background. It uses port 5000. I'm going to map that to port 5000. You don't have to do that. You can say it uses port 5000, but I can map it to 8080 or whatever. That's because if you had 2 applications using the same port, you'd have to change one of them, right? You can't have 2 applications running on the same port. That's just physically impossible. Although with Kubernetes, you can also not specify the port, in which case Docker will randomly assign one, which is a bit of a pain if you think about it, because how would you plan to use that service if you don't know what port it's going to be on? Then I'm going to give it a name. I don't have to. And this time, I'm going to call it the name. The container is the same name as the image. If you don't, you know what? I won't. I'll show you what it does. And then I just say, I want to run this image, .NET hello. And see how fast it starts. It's like 1001, 1 second. And on the background, you see it running in the PowerShell. Now the name of the host isn't rel cdk. If you look closely, you'll see it's the first 12 bytes of what was returned, which is the Docker container ID. If I want to look at its word running in Docker, I can do Docker PS. And look what it does when you don't give it a name. It's wrapping around. It's called Stoic Lamport. It does a adjective underscore famous person's last name. So you get like drunken Einstein or crazy Bell. So if you don't give it a name, it makes it up. Typically, I think you're probably going to want to name them, right? So you can kind of manage them. Because if you go to stop it now, Docker stop, I have to know the name. Although you can tab complete. Whereas if you were scripting it, you would give it a name because then you would know what it is. Interestingly enough, Docker takes longer to stop than it does to start. And you see in the background now in the PowerShell script that it's not working. Get out of that. Okay, back to here. Did it again. I'm 2 for 2. Now, Kubernetes, this is where the fun begins. And all you need to know about this slide right here is on the left where it says master Kubernetes. Kubernetes is just managing all the Docker stuff. Let's just put it that way to keep it simple. And see where it says pod? Well, so the Docker logo is a whale with a container on its back, and a plural of whales is called a pod of whales. So that's where that comes from. But that should give you a hint. You can run multiple containers in the same pod. Now you can start to see already what Kubernetes is going to be like. Okay, so now if you can run multiple containers, can you run multiple of the same image? Can you run 4 of this service? Yes, you can. What about the fact that they all run on port 5000 or port whatever? Kubernetes takes care of that for you. That's awesome. I mean, that right there just saves you a lot of work. I mean, one of our biggest competitors in this marketplace is Kubernetes and DIY, because you know how we are as developers. It's like, well, I could just write that. Yeah, you could. I mean, we spent who knows how much money and hours building it, but OpenShift. But go ahead, knock yourself out. But it seems tempting because you're like, well, if you assign a random port and you intercept that, and then you could store it in a table and you can do lookups. Yeah, you're just going down a road you really don't want to go down. But Kubernetes is where the fun starts. So let's take and build a container image and run it in OpenShift, which is Kubernetes. I'm trying to stress that. I want you to know that. So I have a mess on my desktop. So I have, where is my stuff? I have this thing called OpenShift, which is basically, Minishift, which is a small, quick install of OpenShift that runs on my local machine here. So that's what the black and green one is. We can ignore it, except for here's where I'm running. That's the URI of my service, OpenShift. That's important to know because that's where I'm going to log into. That's where all the action's going to happen. That's where everything's going to run. Well, it's no big deal now because it's local, but that could be in Azure. Right? You can run OpenShift in Azure, and then that would be the URI you're using. So before, when I built the image, I built it on my local PC. Now I'm going to build it and put it in my OpenShift system, which we could imagine that it's in Azure. So I have, of course, a script for that I'm going to run. And before I launch that, let me show you this. So here's the OpenShift platform dashboard. So I'm logged in there. I need to create a new project. So bear with me while I get this. One of the hardest things is getting positioning stuff, right? OC login. I think I'm already logged in. Okay, OC new project. So I'm going to create a project, and this is just like a namespace, like a project. We all know what that is. And you saw in the background, it's already you created it. Now, if I click on there, you can do everything at the command line or here in the web, but everything should be command line, right? I mean, isn't that what Jeffrey Snover says? I agree. Like, you can add your project, you can have it build from source and pull from GitHub, and then you can have it that it automatically does it. I don't have the .NET one installed here, but we do have a build for .NET. In other words, I can just say every time I do a pull request, accept a pull request, it fires off the webhook. It gets intercepted by OpenShift. It pulls down the source code and does a build. And in fact, we even have a Jenkins pipeline. It can do the whole Jenkins pipeline testing and all that. And if it passes, it'll put it into OpenShift. That's all, and that's handled by Kubernetes in a really cool way. That's what's called a rolling update. It builds a code and just replaces what's there elegantly with no downtime. It's very slick. So you can build from source. So you could, as a .NET developer that works in Windows, you can sit in at your Visual Studio and check the code in to a Git repo, and then have it automatically show up running here in Kubernetes, right? Build it and run it. So you don't even have to leave the comfort of your Visual Studio if you don't want to. But you can also, you can do it from Mac or Windows or RHEL, wherever you want, with all the tools we have now. But that's neat as a .NET developer, that you don't really need to leave your area of comfort. So I've created this project. I'm logged into it here. Now I can create V1, which is just version 1. So now the script in the blue screen is running. It's going to create a Docker image, or container image, and upload it, if you will, to OpenShift, which is, in my case, just happens to be in my local machine. But again, this could be running in Azure. And there, now in the background, you start to see some things happening. And over here, I have a watch to watch the OpenShift app come up. And when that app is available, we should see it come up. 192, 168, 99, 100. So there it is. Now it's running in a Kubernetes environment. Now the difference is, remember before we had the first 12 bytes of the container. Now we have a name that we created over here, right? It automatically created a route to it, so I don't even need a port. So in this route, this is a default, but you would, in your real world, you would create one that makes sense. So Kubernetes takes care of what's called routing, right? So it knows where to send the request. It takes care of load balancing. So if you have multiple ones running, it knows where to send it. So that's where you start to see the goodness. So there's one running for R46C. So if I scale this up to 3, watch what happens back here. By the way, you wouldn't sit there on Black Friday and scale up manually like that. When your online store, you have settings that you can, program scaling up and scaling down. You don't need to sit there all night on a Thursday night after Thanksgiving doing this. So now we should have 3 pods: 4R, DK, and QK are the unique identifiers. Now the neat thing is, this is the same service. It's all running in .NET. This is C# code. There's no mirrors. They're all running on port 5000 because Kubernetes magically took care of all that. And every time you do a request, Kubernetes is right now it's doing round robin load balancing. In other words, it's hitting the first one, then the second one, then the third one, then the next request goes back to the first one, and so on. You can do that. You can do random. And there's a third one I can never I think it's weighted. It doesn't matter. Kubernetes is taking care of all this for you. In other words, you can program which one to use, but it's doing all this. Like, this is great. All I need is a URL, and now I'm scaling stuff up, and I've got C# code running as a microservice. And by the way, it doesn't have to be a microservice. This could be I could do a .NET new MVC and create an MVC website and stick it in here and run it. and scale that. The other cool thing you can do is you can do a Docker run Microsoft / MS SQL Server and run SQL Server 2017 in a Docker container. So that's totally outside this talk, other than the fact that it's using Docker. But think about it as a developer. So when you want a database now for your application, what do you do? Like, you have to go to the operations and database people and say, I need a database. Just imagine just doing Docker run SQL Server and you have a database. That's pretty cool. And it's also cool because when you shut it down, it goes away. So you can get, I don't want to say sloppy as a developer, but you know how cool it is as a developer where you can just blow stuff away and start over and you don't really lose the good stuff. I mean, we all love that. Well, you can do that with a database. That's pretty slick. So here we are running. We have 3 of them running. Now we're going to go back, and I have mastered PowerPoint. I'm so psyched. We're going to talk about the blue-green deployment, and we're not going to talk about my artwork. I don't know why I had the blue and the greens not aligned, but I did that on purpose. Sure. So the blue-green deployment basically is we're going to go from version 1 to version 2. And the benefit of it is you can switch very quickly. Now, theoretically, you would never roll back, right? Because you'd say, well, we did all the testing. And in fact, in the DevOps world, there are those who argue that you should never roll back. If you're doing microservices and you're doing 10 deployments a day, yes, I said that, 10 deployments a day, and if number 8, something goes wrong, instead of rolling back to 7, just go forward to 9 and just fix it that way. There is a school of thought that says that. And like everything else in IT, it depends. But being able to switch back quickly is really cool. There I go saying cool. It's very powerful. So let's look at a demo of that. So we have our 3 pods running here. We've got in the background we have our, by the way, this is really cool. This is PowerShell running in Windows in Parallels on my Mac, talking to my RHEL VM, the service running in RHEL VM. I just think that's pretty neat. So we have to run our next script, which is create v2. So what it's going to do is create another version and switch the route up here at the top to the second version. I'm going to scale this to 1 just because CPU cycles. I'm running this on a laptop. This isn't a server, so cut me a break. So watch this route here. It'll drop down to the second one as soon as this one fires up. Notice in the background, we're putting in version 2. Let's see how much downtime we have. Where this? Oh, hey, gee, 0 downtime, just like advertised. It's almost like I've done this before. So now we have version 2, and it's running in, the way it's supposed to. Now that's cool. That's powerful. And then I have switched to v1. Again, watch the PowerShell in the background. When I run switch to v1, let's see how long it takes to switch back to v1. Say we found an error and like, oh, you know what, we forgot to test something. Go back to the previous version. 1001, 1002. So under 2 seconds to switch back. Probably 1 second if you clocked it. So just like that, we switch back, and then we say, well, no, we can go back to version 2, and just like that, it switches back. And again, there's no downtime. The requests are all getting handled by Kubernetes. It has a thing called a readiness probe, and when something is ready, then you can have access to it. When it's not ready, Kubernetes is like, no, just hang on a second, wait a minute, and then when it's ready, it gives it to you. So that's the blue-green. The cool thing is, version 1 is still running, right? We just changed the routing, which is very slick, very fast. So think about in your environment that you work in to be able to switch back that quickly if something goes wrong. But maybe that's not how you want to do it. Maybe you want to do what's known as the canary deployment. Pardon me. The canary deployment is based on the idea of the canary in the coal mine. The old miners would take a canary down the coal mine. If the canary would stop singing, or worse, it would drop dead, there was probably natural gas or too much carbon monoxide, and you had to get out of the mine because there's no other way to detect it back in those days. So the little yellow dot is your application, your microservice, and you move it along to development. And so you develop it. And now remember, this is really neat. So you create this image, and now to QA, you just give them the image. You're not giving them source code. They don't run installs. You just give them the image, and they run it. I mean, let's be honest. You save time there just by not having to run installs and copy source code. And I forgot this library. And oh, by the way, do we have the same environment in development that we do in QA, or do you have a different dependency, a version on your dependency? So you can see another thing you get from, it just makes life so much better. So in QA, then you go staging, then you go into production, right? We start it, and then we create a route to it. Now at this point, the canary deployment, the idea is you route a small percentage of your traffic to the canary, to version 3 in our scenario. And then you see how that goes. Is it being successful? You're monitoring it. Is it fast enough? Is it successful? Is it working? Are we getting the results we expect? If you are not getting the proper results, you just back up. You just take that route out, and you're good. No harm, no foul. If you are seeing results, you route it to more people. Now, the reason I'm making the yellow dot bigger is not necessarily to represent the application scaling up, although it probably would as you add more traffic to it. It's to represent more people using it. Okay, it's not a performance thing; it's a number of people. Also, what I'm not demoing today, the part right here, the routing. There are intelligent routing systems and software, like I think Istio is one, that allows you to do intelligent routing in software. Like, is the user's first name John? Is the user one of our top customers? Are they east of the Mississippi? However you want to segment your audience to test the canary deployment, right? Maybe you want to just make sure certain people get it. I've heard this referred to as A/B deployment. I've also heard that people argue that it's not A deployment. I'm sure someone will use it that way. It's not the intention of it, but we're all creative. So you keep scaling up, and eventually everything's okay, and it becomes your version 3 in our scenario. It becomes your new version. So again, the beauty of that is you can scale back and forth any way you want. So let's take a look at how that works. And again, I have scripts to do this. I can show you the script. It's not important that you know exactly, what's in the script. Okay, yeah, there's a script. The top is to eliminate downtime, but all this goodness, you don't need to know exactly what it is. But you can see one of the things it's doing. It's patching some metadata attached to my services, and it patches a route. So we should go ahead and run this. Create v3 and go back to Chrome. Now we're in v2 right now. You can see that here in the background with PowerShell. The script is running, and then over here, interestingly enough, version 1 is still running. No one's using it, but it's still running. Now watch what it does here. It's taking the running version 2 and saying, well, I'm going to replicate that as part of my version 3 system, and then it's also going to add a version 3. Now back here, you'll see a v2, and then you'll see a v3 come up. Just wait for it. It's coming. There it is. Now, if I take version 2 and scale it up, I should have done that before I started. Oh, I just scaled up version 3. Well, it doesn't matter. The point is, if you watch what's going on here in PowerShell, you see a v3, v2, v3, 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 v2. So that's the mix. Remember I showed you how you have a mix of making it more or less users. So that's where that comes in. So that's what we're doing now. Now we have Canary. Now we have 2 different versions running at the same URL or URI. Again, your intelligent routing would pick up information in the header and determine, how to route this. But that's how the Canary works. That's pretty slick. Okay, so you can just, all right, so version 1 still running. You can shut that off. All right, we don't need that. We can scale this to 4 and turn off version 2. And we should go straight to all version 3s here in a second. And again, we never saw a downtime. And there's all the version 3s running. So that is all that. Now we're going to get in the circuit breaker. But before I do that, this is my favorite part of the demo. I'm just going to destroy everything. And I used to think, oh, it's just so much fun to wipe it out. And now I realized it's not just fun. So OC delete, it's my project called my.net. And I'm going to do a cascading delete, which means it just wipes out everything. And if you watch here, through the magic of Ajax, I guess, it's going to go ahead and know that, hey, everything's going away. The services are, if you look at the PowerShell, the services are gone. I used to think this was just like therapeutic to wipe everything out. Then I realized it's actually important because as a developer, again, I mentioned the database, you know how sometimes I just want to wipe it out and start over. Especially when you're developing and you're like, did that work? It's like, if I run it again, will it work the same way? So it's actually that kind of important. All right, so that's done. I wiped out everything. I can probably cancel this now because I'm not going to use it. Now we're going to go back here and boom. The circuit breaker pattern. I have this gorgeous backyard that has a swimming pool and a patio that I built out of hardscaping and a fire pit and landscape lights. It's absolutely beautiful. It's one of those jobs that you would never do it if you knew how much work it was. But we did this, my wife and I. It's just stunning. But I had my friend who's an electrician do the wiring underground, and every time it rains, the electricity shuts off. And I have GFI, ground fault interrupt, but I'm like, it's not supposed to just stop when it rains. I get pretty mad at him, like, you really don't know what you're doing, do you? And so it pops open. I have no power. Now my pool has no power. My fountain has no power, the lights. So I'm out there with a shop vac, and I'm draining the lines out, pulling water out, the lines, trying to get everything dried off. I go back in the garage. I had to move my car to get to the circuit breaker box. It's a hassle. And I finally hit the reset, and the thing pops open again. I'm like, what is going on? So I'm out there, and I'm trying. Eventually, after several hours, it just dries up, and then it works. And, I hit the button, and finally the circuit stays closed. Right? That's how circuit breakers work in our houses, thankfully, or we all have probably burn our houses down by now. When it's open, it's not going through. When it's closed, it's going through. It seems kind of opposite, with the term open usually seems good, right? If you're open for business. But in this case, the client runs the circuit breaker, and it's trying to reach the server. When the circuit's open, the client, let's say a website, is not reaching the server. The service. And when it's closed, everything's working normal. Situation normal. Snafu. So here's in the orange, here's a little state diagram. In the orange box, with my wonderful artistic skills, when you're in that orange box, you are not attempting to reach the service. So here's how it works. Everything's working fine. Everything's closed. There's a failure of some kind. And again, you can program all this in and set up your configuration. Excuse me. My favorite example is an overloaded server, right? It can't keep up, and it hasn't scaled yet, or it doesn't scale because whoever did it didn't make it to scale. So what do? I love this. So we try again, right? And so if everybody keeps retrying, it just keeps hammering that poor server. It's like, yeah, I'm overloaded, so just give me more, and that doesn't work. So it pops open. The circuit pops open. And then you wait. In my example, I wait 8 seconds. And when that wait time is reached, it goes to what's called half open, which says, okay, let's try hitting the service. If we succeed, we go back to closed. Everything's good. If we fail, we go back to open and restart the 8 seconds. At any time, and again, the seconds you can configure. At any time during those 8 seconds, if the server fixes itself, I'm still not trying. I have to wait those 8 seconds. That's the key to remember. So if you fix everything, it doesn't immediately, it waits for its next half open and then gets success. Right? So what you can do when it's open, and this is the powerful part that you as a web developer can use now, is you can provide a result that the service would have given you or should have given you. And you say, well, that doesn't make sense because the idea of a service. Well, there are instances where it does. And let me give you an example. I visit my sister in Florida, and I want a new mouse. So I log on to the big box store, and it says, hey, I see you're in Sun City Center, Florida, and our nearest store is 10 miles up Route 75, and you can come pick up the mouse today. I'm like, oh, cool. It knew where I was because it took my IP address and did a geolocation. You know, it has a service to do that. But what if that service was down? So what if you had the circuit breaker pattern? What would you do? You might come up and say, hey, type in your zip code and I'll show you the nearest store. So in other words, you have some control over how it, quote, fails, rather than having it just say, we can't find a store. So that's one benefit. Another one might be you would log on to Netflix and it comes up and says, hey, Don, welcome back. We see that you watched Penguins of Madagascar and you watch Phineas and Ferb, so we want to suggest Mastermind because you like these animated kids movies. Oh, cool. It knows my stuff and knows what I like to watch, so it recommends it. But if that service is down, what does it do? Does it sit there and go, we can't make any recommendations? No, it can come up and say, hey, welcome back. These are the most popular movies in the last 5 days in your state or in your country or over the world. So it has an alternative path it can take. It might even come up and just say, here are the new movies. You know, so you as a user, you don't recognize the failure. And it gives you as a developer a lot of power. So let's do that demo. And this is a real simple demo. I have a thing called Circuit Breaker console app. And it just runs and basically returns it does a get against port 5000 and returns whatever I'm supplying. I'm sorry, I have a hard time typing and talking at the same time. So here's this thing called howdy. It just returns the word howdy, I think with an exclamation point, because that's how people that say howdy, that's how they don't say howdy, they say howdy. So when this starts up over here, so see the hello? That is the circuit breaker working because this app hasn't started yet. It's saying hello. Like this, it's like mimicking the idea that you're not sure that it's down. Like you as a user don't know. Now you can see it saying howdy. Now the system's up and running. Everything's fine. You're getting back the response you want. What I can do is I should be able to go here. And get the greeting. Bear with me. And there's howdy, right? There's at the URL. Because I have some switches here. I'm going to type in, I'm going to mimic the server slowing down and watch the background, the requests 73, 74, etc. Watch what happens. Slow down. Now it went to hello. So just like that, the service dropped, or it took too long, actually. And it's saying, well, hey, it took more than a millisecond, so I'm just gonna not even hit it. So now the service is down. We're still getting not really a response. We're mimicking it, but the user is getting a response. So we go over, we figure out what's going on. Maybe it didn't scale up as quickly, or maybe remember we did the blue-green. Maybe we put the version 2 in, and it didn't work. Switch it back. So we go back to normal speed now. And watching the background. Remember, even though I fixed it, it has to complete its 8 seconds or whatever you program it as. and now it's back to howdy. So that is the circuit breaker pattern. You can use that today, and that just represents one sliver of what you're going to need to know to do microservices. There's logging, there's monitoring, there's so much involved. But hopefully this gives you an idea of where to start, and you can use this today. So that's what I have for you today. That circuit breaker pattern comes from the Poly project, which is an open source project. I recommend you looking at that. I recommend everybody get involved in open source. Here are all the resources I recommend. If nothing else, the fourth one down is the best. live.asp.net. That's awesome. And you can hit me up on Twitter and email. And I'm ready for questions.
Cool, fantastic. Get that stretch. You deserve it, Don. You worked hard. Couple questions here. This one's a little bit more kind of back at the beginning. I think someone was a little confused. Maybe you could take just a brief moment and then juxtapose and explain to us the difference between a container and an image, because I think sometimes that can be confused. Container, that generic term.
Yeah. Okay, so it's here. When you compile, look at it this way. If you compile a program, it just sits there, right? You build an exe, and you have an exe, and then you run it, and it's an application. So when you build an image, it just sits there. It's just a pile of bits. And then when you run it, then you use the word container. It runs in a container. That's the best way I can
Okay, so a container is a running image. A container is an instance of an image.
Yes.
Okay, that makes sense. And another question here, and I think this is a question that people have always had when they're learning about containers is, well, we hear that Kubernetes is the new thing, it's the hotness. There are other orchestrators. Could you explain the difference or the benefit of Kubernetes versus Docker Swarm or the other things? How many orchestrators are there, and how does one make a decision about which one to pick?
Those are good questions. I don't know all the answers to that. I will say that we have chosen Kubernetes, and I think the world at large has. Kubernetes is part of the CNCF, Cloud Native Computing Foundation. Mm-hmm. Kubernetes was developed by Google. I'm not sure of the differences between it and Swarm.
Well, let me ask you this.
Kubernetes is awesome.
In all technology worlds, there's always like beta and VHS. You know, there's HD DVD, there's Blu-ray. Exactly. Docker won the container wars, and then we had the Open Container Foundation is going to get together and putting that stuff together. You believe that Kubernetes is a great choice for an orchestrator, and that's the one you've chosen, and you feel good about it.
Yes, and we, as a company, we have. That's why we built OpenShift on it, and it's without speaking not as Red Hat, but as Don Shank.
Sure. We're just technologists having a chat.
Kubernetes has won. I'll just put it that way.
Okay.
It's really great.
Well, it sounds like you appreciate it, and we appreciate you and the work that you put into this presentation. And as you can see on the slides right there, you can take a look at all of his information up at github.com. You see that there's Red Hat -.net -MSA. And of course, you can talk to Don on Twitter at Don Schenk. Thank you so much. We're going to take a quick break, and we'll be right back with even more .NET Conf. Remember that we have 2 tracks. You can switch between them. I'm just one track. And tomorrow, Beginner Day. Please tell your friends and your beginners all about it. We'll see you soon.